So let's talk about this Mod 6 and 7 group test. Now, you probably received a test back, your group test back, and I'm hoping that you weren't necessarily too pleased with the grade. The grades weren't all that great, but let me talk to you about the way the group test works. The group test, no, hang on, let me step back a minute before I get into this too far. Most of the IM3 teachers treat this pretty similarly. If you are not in Mrs. Franken's class, then please ask your teacher for their specific way that they deal with the group test, or the way that they expect you to write your answers, things like that, because they are the ultimate authority on how your test is going to be graded. As for Franken's class, let's see. Your group test is basically your practice test. It only counts for 20 points in your grade book. Now, it does count as a 20-point test, not a 20-point assignment. So that does mean that it goes to a category that's weighted at 70%. So it does matter, that's for sure. Now, I always get comments of, oh shoot, I just got a, let's say I got a 40% on the group test because the people I was working with just, they didn't prepare and blah, 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 or whatever the reason is. So here's how I deal with that. Let's say on your group test, your group got a 40%. So for that 20-point assignment, you have a 40%. What I do is, if you study and you go over the group test and you learn the material, and then come time for the individual test, which is usually the day after we go over the group test, if you are able to improve your grade, let's say that you get a 70% on the individual test, that one is worth 100 points. That is the big guy, okay? That's the one you really want to do well. So let's say you get a 70% on the individual test. What I do is I go back to the grade book and I take that 40% out and I give it a 70%. Because that tells me that you learned what you needed to learn and you were able to display that to me on your individual test. Now, that works for any grade. So if you get a 90%, I will go back and change it to a 90. But you only get one shot at the individual test, so you got to make it count. So, does it go the other way? No. So let's say that you were with all the smart kids, and on the group test, you guys scored 7, let's go high. Go big or go home, right? Let's say you guys got a 90% on the group test. You had the smartest kid in class in there, and you guys just rocked it. But let's say on your individual test, you got a 60%. Your group test will never, ever bump up your individual test. So if you get a higher group test grade, this goes in the grade book for your group test, that goes in the grade book for your individual test. Okay? So when it comes down to it, the one that matters the absolute most is your individual test. It can control your group test. However, the group test needs to be used as a gauge. It should show you what you know, what you don't know, what you need to study. We will always go over the group test before we take the individual test, which is why I'm making this video. As I go through this video, I'm going to do every problem from the group test, and then that becomes your study guide. So you're going to want to pay attention to what I say about what I'm going to be looking for in your answers. There were some problems, 1 or 2 problems, where people were writing their answers in the wrong format. This is where I'm going to hopefully clarify any of that stuff. So hopefully you find this helpful. Let's go ahead and clear the slide. Oops, I did not want to do that. Undo. There we go. Okay, so let me just erase what I had written so that I can get this show on the road and get solving some problems. So, again, these are the exact problems from your group test. So, question number 1 says, write a polynomial function of least degree with integral coefficients that has the given zeros. First thing, integral coefficients. That means no fractions, no decimals, no radicals, no i's. Everything's got to be a nice number. And what they're giving me is they're giving me the zeros. Another name for zeros is roots. Zeros and roots, kind of those two words are used interchangeably. Now, you learned that whenever you have a radical, this is called the rational root theorem, that the positive and the negative of that radical are both roots. So I have negative radical 3 as a root. That means that positive radical 3 is automatically a root as well. So I actually have 2 roots just from that first one, even though they only listed 1. And then they tell me that 2 is a root, but it has a multiplicity of 2. What does that mean? It means it's going to happen twice. So starting off with with the negative radical 3. That would become in a parentheses x plus radical 3. Remember, we changed the sign? Now I'm going to put the positive radical 3 in parentheses. That would be x plus radical 3. And then the 2 with a multiplicity of 2. If that's a positive 2, it's going to be x minus 2 in my parentheses. Now here's a mistake that some people did. They would just put the squared right there, which is fine. However, that does not mean that this becomes x squared minus 4. That's not what it means. It means that you're actually going to have to FOIL it out. So I'm going to write it twice because it's easier for me to FOIL it if I'm writing things twice. I'm going to kind of do these separately. I'm going to multiply these 2 first, and then I'm going to multiply these 2, and then I will multiply their results together. So x times x gives me x squared. X times radical 3 gives me positive x radical 3. I made a mistake. Do you see my mistake yet? Well, here's my mistake. I have a positive radical 3 and I have a negative radical 3 as a root, which means that I need to have a plus radical 3 and I have to have a minus radical 3 as my roots there. Whew, glad I caught that there because that would be a pain to figure out later. So let's see, x times x gives me x squared. That makes this one, let's fix this all up here. Okay, x times x is x squared. X times negative radical 3 is negative x radical 3. We okay there? Positive radical 3 times x is positive x radical 3. And radical 3 times negative radical 3 would be negative radical 9. Well, what is negative radical 9? Isn't the square root of 9 just 3? So it's really just minus 3 at the end, not radical 9. We're not going to write the radical. What happens when I have a negative x radical 3 and a positive x radical 3? They cancel out. And I'm left with the x squared at the beginning. So this whole thing became x squared minus 3. Okay? Now let's multiply the other ones. X times x, x squared. X times negative 2, negative 2x. Negative 2 times x, negative 2x. And negative 2 times negative 2 is positive 4. Combining my like terms, I have x squared. That becomes minus 4x. And then plus 4. So now I have both of those results in parentheses, so I'm just going to multiply these together, and then I'll have my answer. So let's see, x squared times x squared is x to the 4th. X squared times negative 4x would be negative 4x to the 3rd. And x squared times 4 would be 4x squared. Negative 3 times x squared would be negative 3x squared. Negative 3 times negative 4x would be negative 12x. And negative 3 times positive 4 would be negative 12. So let's combine our like terms. It does say write a polynomial function. So I'm going to say f of x equals, and we need to make sure we write our answer in standard form. It's called standard form because it is standard, which is something you always do. So x to the 4th has to come first. And then let's see, I only have one x to the 3rd, so minus 4 x to the 3rd. Positive 4x squared and negative 3x squared gives me positive 1x squared, and we don't write the 1 as a coefficient. It's just implied. Let's see, minus 12x and minus 12. So there's my polynomial right there for number 1. Okay, hopefully not too bad. Number 2 is fairly similar. It was called the rational root theorem and the complex number theorem, I think it was called, off the top of my head. It says that if you have an I as an answer, or as a root, I should say, then the positive and the negative are both roots. They come in pairs, just like the radicals. So if 4i is a root, they're kind of telling me but not telling me that negative 4i is also a root. Okay, so we got 3 roots here, which means I'm going to have 3 parentheses. Now, how do I make 1/5 into a parentheses? I don't want to write this. Do you want to FOIL with a fraction? That would stink. Don't do that. If you remember, the 5 ends up becoming the coefficient of the x, and since this is a positive fraction, I'm going to put a minus there, and the numerator is what goes there. So we have the denominator and the numerator. That's how it ends up working together, and I'll show you why that works. Oops. Because if I took 5x minus 1 and I set it equal to 0, adding 1, 5x equals 1, divide by 5, there's your 1/5 as an answer. Okay, so putting the denominator as your coefficient and then the numerator on its own at the end as the constant, that's just a shortcut way of doing that. Okay, so let me erase that. And let's see, let's try and erase it without erasing my problem. Made my eraser too big. Okay, so 5x minus 1. My other 2 parentheses would be x minus 4i and x plus 4i. Now, something I didn't mention on the previous problem that I'm going to mention now is whenever you have i's or radicals, multiply those 2 parentheses together first, because it will get rid of the i's or the radicals. The other problem, it didn't really matter because I had the 2 written first together, so I went and did them first anyways. This time I'm not going to mess with the 5x minus 1 until I have FOILed the x's and the 4i's. So we're going to start there. So x times x is x squared. That should be easy. X times positive 4i would be positive 4xi. For our purposes, it doesn't matter if you write ix or xi. However, standard form for imaginary or complex numbers has the I coming last. Negative 4i times x would be negative 4xi. And the last one, negative 4i times positive 4i, would be negative 16i squared. So, let's see what we've got here. Positive 4xi and negative 4xi cancel out. I have x squared minus 16. Now I'm going to hold off on the I squared for a minute because let's think about I squared. Our definition of I is that I equals the square root of negative 1. So what does that mean that I squared is? Wouldn't I squared be the square root of negative 1 squared? Isn't it just the same as squaring that? And what happens when you square a square root? It cancels. So I squared, hang on, I'm showing that wrong. What happens when you square a square root? You end up with I squared on this side and negative 1 all by itself. So this is the part that we got to remember, that I squared equals negative 1. You never have an I squared in your problem. You always have to change it to negative 1. So instead of I squared, I'm going to write negative 1. And so I have x squared minus 16 times negative 1 becomes plus 16. Now I'm going to bring down that first parentheses and multiply the 5x minus 1 through. So 5x times x squared would be 5x cubed. 5x times 16, that's a big number. I think it's 80x. Checked it on my calculator. Negative 1 times x squared would be negative x squared. And negative 1 times 16 is negative 16. Now it's not in standard form, and I need my f of x. So f of x equals 5x cubed, that's a really bad 3, plus 80x, nope, what's Franken doing wrong? Too late at night to be doing this. Got to do my x squared next, so I have to do minus x squared. now my plus 80x and minus 16. So, will I take off a point if it's not in standard form? Yes, I will take off a point if it's not in standard form. That is important for you to know. So, on your test tomorrow, there will be 2 problems just like these. Each one of these, by the way, was worth 9 points. So those 2 points together were worth 18 points. So if you skipped both of those, you're already down to an 82%. Don't skip them. Figure out how to do them, study it, and then come back on the day of the test ready to go. Okay? All right, let's go to the factoring ones. Factor each completely. Now, each one of these 3, the first step has to be find your greatest common factor. So if I look at number 3, what do those 2 numbers have in common? Well, the biggest number they have in common, unfortunately, is a 2. Now, some people wanted to just divide by 2. I get where you're going with that. It's a good thought, but you can only do that if there's an equal sign. With no equal sign in the problem, I actually just have to take the 2 out. So if I take the 2 out, that leaves me with 16 x to the 4th minus 81. Many of you noticed that this right here is a difference of squares. Okay, we like a difference of squares. So that means it's going to split into 2 parentheses. Square root of 16x to the 4th is 4x squared. So that's the first thing that goes in both parentheses. Square root of 81 is 9. Make one a plus, one a minus. Okay? Now some of you stopped right there, which is a problem because right here we have another difference of squares. Now, I can't do anything with the 4x squared plus 9 because a sum of squares I can't do anything with. Feel free to try and snowflake it. Doesn't work. But 4x squared minus 9, that I can do something with. Square root of 4x squared would be 2x. So that goes in the beginning of both parentheses. Square root of 9 is 3. Make one a plus and one a minus. I am completely done now. Notice that that 2 I took out at the beginning, I've just been continuing to write it down with everything because if I forget it, I don't have it factored completely. So I got to keep that with it. Okay? All right, number 4. Again, first thing I got to look for, do they have anything in common? All of these terms have a 5 in common, but guess what? They also all have an n in common. So I got to take out a 5n first. Once I take out the 5n, I'm left with 8n to the 3rd plus 16n squared minus n minus 2. Now what I'm going to use here, what method of factoring I'm going to use is I'm going to use something called grouping. So what I do is I split those in half. Looking here, what do these have in common? They have an 8n squared, and left inside would be n plus 2. Over here, I bring down the negative sign, that first sign right there. I'm going to bring down that negative sign. Okay? Now, do n and 2 have anything in common? No. So what I do is I put a 1. Because nothing in common, well, they're going to have a 1 in common. Everything has a 1 in common. Everything's divisible by 1. But I put that 1 there so that I remember when I put my parentheses at the end, I know a 1 goes right there. So let's see. Negative 1 times n is negative n, and negative 1 times positive 2 gets me that negative 2. So what does this mean? I've got my matching parentheses. That's a good thing. So one of my parentheses is n plus 2. The other parentheses is 8n squared minus 1. And of course that 5n that I took out at the beginning, I can't forget to put that there because that's part of the complete factorization. Now, I will always get questions. Does it matter whether you write the n plus 2 first or the 8n squared minus 1 first? No, it does not matter. This right here is equally as correct and would also get get full credit as an answer. It doesn't matter. As long as you have this parenthesis somewhere, that parenthesis somewhere, and this number we like to see out in front, then you are all set. Okay? All right, so let's move on to the last factoring problem. What do I look for first? What they have in common. These ones have a 3 in common, and I think that's it. That leaves me with 8x cubed minus 9, nope, not 9, 27 y cubed. So what we have here is a difference of cubes. Now, do you notice that I didn't give you the formula anywhere? That's a key. That should be a big signifier that you're going to need to know that it's not going to be provided for you on the test. So let's see. There's my 3, and let's think about what is it to the third. Let me add some extra parentheses here, though. What is it that to the third minus whatever to the third, because I'm going to have to plug it into that formula. So what to the third power gives me 8x cubed? That would be 2x, because 2 to the third is 8, x to the third is x cubed. And 27y cubed, that would be 3 and y, correct? Because 3 to the third gives me 27, and y to the third gets me that y cubed. Okay, now let's go back for a minute and let's think of our difference of cubes formula. Our difference of cubes formula is a minus b, and then a squared plus ab plus b squared. Difference of cubes always has a minus there. Sum of cubes would have a plus right there. And then this one is the opposite sign of whatever was in the first place, and that ones are always positive. I did a video on that one, and I used the SOAP acronym, S-O-A-P, to help you remember that. Feel free to check out that video. So, let's see. Let's go ahead and write our answer, because we should be done here. I have a 3 out in front, and let's do a minus b. That would be 2x minus 3y. Again, I'm only looking at what I have written in red there. I'm ignoring the cubes now at this point. I'm just looking at those two values right there. Second parentheses, a squared. A squared means I have to square both of those. So 2 squared is 4. X squared is x squared. Plus a times b. 2x times 3y would be 6xy. And then finally plus b squared. That means 3 squared and y squared. And that's my full factorization. Will there be some more difference of cubes tomorrow? Yes, there will be at least one of them. So make sure that you are familiar with those. Okay? As far as points are concerned, each one of these was worth 7 points. So 7, 7, 7. Those were your point values there. Okay? All right, let's finish off the front page. Synthetic division. I love synthetic division, don't you? Maybe it's just me. Okay, I'm trying to find out, is n plus 3 a factor of this guy? So what's my box number? -3. Remember, you have to change the sign there. Now let's list our coefficients. Are we missing any coefficients? Yes. 2, 17. I have to fill in a 0 because you notice there's no n cubed right there. That's why I have to put a 0 there. 45 and 36. So let's do our synthetic division. Bring down the 2. That gives me -6. 17 minus 6 is 11. Times -3 is -33. 0 plus -33 is -33. -33 times my box number, which is -3, gives me +99. We're getting some big numbers here. 45 plus 99 is 144. 144 times -3 is a huge number. It's -432. Plus 36 is -396. Is my remainder 0? No, it's very much not 0. So is it a factor? No. If it is not a factor, you do not need to fill out factored form. Your answer is just no, which means there is no, I shouldn't say there is no factored form. It means that factored form does not include n plus 3. Okay, that problem right there was worth 3 points. I know it said that 14 points total for 6 and 7. It's actually 10 points total for those two. Okay, so ignore that 14 points. So that one was 3 points. Number 7 is worth 7 points. So we need to see, does -4 work as a box number here? So let's see. Missing coefficients. 1, 7. Doesn't look like I'm missing any. So I can just use all of the ones that they're given. That brings down a 1, -4. That gives me -4. 3 times the box number is -12. 2 and -8 and 0. I got a remainder of 0. What does that mean? Yes, it is a factor. What it also means is that when it says factored form, my first parentheses is n plus 4. You must include that one. Okay? Some people only put the 2 parentheses they got from here when they factored that. That's great, but when you FOIL those out, you get a second degree equation, not a third degree. You only get a third degree if you include that n plus 4 from the beginning. So, I had n to the third. Now I have n squared plus 3n plus 2, and I'm going to snowflake that. So 1 times 2 is 2, and 3, two numbers that multiply to get 2 are 2 and 1. Those are my only options. Thankfully, they add to get 3. I put a and n on the top, and a and n on the bottom. On the other side also. So let's see, n over 2, that means I have n plus 2, and n over 1 means I have n plus 1. Okay, so that was 7 points right there. Some people gave me a polynomial here. They gave me that where it said factored form. Factored form has to have everything in parentheses. There are not commas. I had people give me this too. There are not commas between them. You are not listing parentheses. You are showing that they are actually being multiplied. That's the point of factoring. Okay, so I do mark off if you put commas there. That changes the meaning of what you're writing down, and we don't want to do that. Okay, all right, let's go over to the back side. Okay, let's talk points here. Number 8 was worth 11 points. That's a big one. Number 9 was worth 9 points. Those two questions together are worth 20 points. For the test, these are the 2 questions that will probably take you the most time. These ones and the next one. So 8, 9, and 10, those are the problems that will take you the most time. So make sure that you have time for those. Okay? All right, so can't even see it now. Number 8, because I wrote over it with the point values. Number 8, you notice a graph is given. That's helpful because we can look at that graph to see what the zeros are. Now, first thing it asked me to do is come up with possible zeros. So I need the factors of the constant. The constant is 18, so I have plus or minus 1, 2, 3, not 4, not 5, 6, 9, and 18. Now my leading coefficient. What are the factors of my leading coefficient? That's 2. So I have plus or minus 1 and plus or minus 2. Please do not just write plus or minus at the beginning and then expect it to apply to all of them. Okay? Just suck it up and write the plus or minus. You only have to do it here. But if you write plus or minus and then all of these numbers in here, like 1, 2, 3, that's not how you notate something in math. It's just sloppy. It's not appropriate. So make sure that you're writing that symbol for all of them. So now I need to set up fractions. So 1 over 1, 2 over 1, 3 over 1, 6 over 1, 9 over 1, 18 over 1. Those are easy. So I have plus or minus 1, plus or minus 2, plus or minus 3, 6, 9, 18. Now putting them over 2. 1 over 2. Got to add that to my list. 1 over 2. 2 over 2. I don't need to put 2 over 2 on my list because what is 2 over 2? Isn't it just 1? So I don't need to include 2 over 2. I do, however, need to include 3 over 2. 6 over 2, that's 3. 9 over 2. And then 18 over 2 is 9, which is already on my list. So that's my list of possible zeros. Yes, you will have one that has a fairly lengthy list like that, and it will include the fractions. Okay? All right, so now, factored form. I need to look for some roots. Really quickly, while I'm thinking about it, I have a fourth degree equation, which means that factored form must include 4 parentheses, and I'm going to have 4 actual zeros or roots. So looking at my graph, I'm going to start off right here. That to me looks fairly clear that it's a 3. Okay? It also, if you notice, it hits the axis and bounces back up. We learned about that's what we call a double root. So it's actually going to work twice for me. So let's do it once, and then we can do it another time, and that should work twice for us. So using my coefficients, do I have any missing ones? 4, 3, 2, 1, nope. So I can just list them as is. 2, -7, -10, 33, and 18. So let's see, I'm going to bring down the 2. 2 times 3, that gives me 6. -1, -3, -13. 3 times -13 would be -39. Gives me -6 times 3 is -18. There's my 0. Ding, ding, ding. I have my first answer, which is 3. That box number worked out. So now, my question is, what did the parentheses look like that 3 came from? That would look like x minus 3. So that's the beginning of my factored form. Okay? I had x to the 4th. This is my x to the 3rd right there. So let's try and get it to come down again, because once it gets to x to the 2nd, then I can snowflake it. Now, because it bounced off there, that is a double root. So I'm going to try 3 again with these coefficients, and we should have another winner. Again, how can I tell if it's a winner? Or if it's a factor, it works. You get that remainder of 0 at the end. So bringing down the 2. 2 times 3 is 6. That gives me 5. Gives me 15, 2, 6, 0. Ta-da! It's a double root. So I'm going to write 3 with a multiplicity of 2. How do I write that in the factored form? Easy. Just make that parenthesis squared. That means it's representing 2 parentheses. Okay? And now I'm down to x squared. So I have 2x squared plus 5x plus 2. And I have to factor that. So I'm going to snowflake. 2 times 2 is 4, and on the bottom is 5. Multiply but to get 4 would be 4 and 1. Thankfully they add to get 5. And I put 2x and 2x. This one isn't going to reduce, so it's just 2x plus 1. This one does reduce to a 1 and a 2, so I'm left with x plus 2. Now I said it was a fourth degree equation, so there were going to be 4 parentheses. Well, I have 2 with the x minus 3 squared, and I just came up with the other ones. The other 2 being 2x plus 1 and x plus 2. So now let's list our other 2 answers. Well, from x plus 2, we're going to get -2. And from 2x plus 1, we're going to get -1/2. And if you need to do the work of showing the 2x plus 1 equals 0, that's fine. Go ahead and do it. If you show your work, it's not just because your teacher's a pain in the butt making you show your work for stuff. You're actually less likely to make mistakes when you show your work. Okay? So, all 3 of those things are what I'm looking for that one. That's probably the longest problem on the test. All right, number 9, factors of the constant. Well, if my constant is 1, guess what? Those are my factors. What about the leading coefficient? Leading coefficient is 5, so I have 1, and I have 5. A lot of people did this one backwards. Constant goes over leading coefficient, so 1 over 1 is 1. Then I have to put the 1 over the 5. That's plus or minus 1/5. A lot of people said plus or minus 5. It's not 5, it's 1/5. So there's my possible zeros. Very short list. There's only 4 possible numbers there. 1, -1, positive 1/5, and negative 1/5. Now those are only possible real zeros. Okay? I could have i's as zeros. So that doesn't mean necessarily that all of my zeros are going to be on that list all the time. So let's come up with our factored form. You notice there's no graph on this one to look at. The reason is my list of possibilities is so small. Why do I need a graph? Let's just work through them. Start off with positive 1. If that works, great, you have one. If it doesn't work, move on to negative 1. I only have a third degree, so factored form is going to have 3 parentheses, and I'm going to have 3 numbers for my actual zeros. So starting off with positive 1, let's just work down our list. 5, no missing terms, nope. So negative 1, negative 5, and positive 1. Bring down the 5 times the box number, gives me 4. Multiply by the box number, add, multiply by the box number, 0. Boom, found them. My first 0 is 1, which means that my first parentheses is x minus 1. Now, if you tried negative 1 first and it worked, that's great. Your first parentheses might look different than mine. Okay? But I just took a third degree, and it's now a second degree. So I have 5x squared plus 4x minus 1. So I'm going to snowflake. 5 times negative 1 is negative 5. And 4, let's see, 5 times 1 is 5. Let's make that one negative. Does it matter which one you make it negative? Yes, because if you make the other one negative, you're not going to add to 4, you're going to add to negative 4. And then I put 5x and 5x. This one doesn't reduce, it's 5x minus 1. So I'm going to put that one there, 5x minus 1. This one does reduce, and it becomes x plus 1. So there's my 3 parentheses for a third degree. Let's come up with our other 2 answers. From 5x minus 1, you're going to end up with positive 1/5. And from x plus 1, you're going to end up with negative 1. Again, you get those by setting those parentheses equal to 0. Okay, that's setting 5x minus 1 equal to 0, solving it, and setting x plus 1 equal to 0 and solving it. Okay, all right, those 2 are the longest. Next one, the next longest problem. Then we have 3 quick, easy problems at the end, and we're done. Find all the zeros of the polynomial using any method. This is a what? A 4th degree equation. 4th degree equation. Which means how many answers am I going to have? 4. Now, I do notice this is x to the 4th and x squared. Let's see if we can snowflake this. If I can't snowflake it, then I have to do it like the problems I just finished doing, coming up with my list of possibilities and working through it. So I'm going to try snowflaking. I need to make my snowflake bigger because these numbers are bigger. I need to be able to fit in there. Negative 225 and positive 16. Well, let me see. 2 numbers that multiply to get 225 and add to get 16 are actually 9 and 25, with the 9 being negative. Then I have x squared and x squared. So this actually does factor. It factors into x squared minus 9 and x squared plus 25. Well, x squared minus 9 goes further because it's a difference of squares. That becomes x minus 3 and x plus 3. X squared plus 25 I can't take further because of sum of squares I can't do anything with. So, what's my root from x minus 3? It's 3. What's my root from x plus 3? Negative 3. There's 2 of my roots, right? And you get that just by setting it equal to 0 and setting this one equals to 0. And now let's set x squared plus 25 equal to 0. People like to jump ahead on this one and tend to make mistakes. I'm going to subtract 25. That leaves me with x squared equals negative 25. Square root, what happens when I have a negative under a square root? Well, first off, I have to put the plus and minus out front because I have a square root. Negative under a square root means you have an I. Square root of 25 then is 5i. So I have plus or minus 5i right there. So 5i and negative 5i. Fourth degree equation, 4 roots. I'm good to go there. Is there another way I could write my answer? Absolutely. You could write this, and that, if you want to, means the same thing. Still represents 4. 4 roots, I should say. Okay? All right. Last 3 problems. These ones should be the easiest, but there were a lot of people that struggled with number 11. And for some reason, people struggled with number 11 because they thought it was a multiplication problem. But there's a couple important things in there, one of which is right there, that's called a plus sign, and one of which is right there, and that's, called a minus sign. That means we don't multiply. So, 5x, not going to do anything with that guy yet. 2 is what I am distributing, so 2 times 2x is 4x. 2 times negative x to the third is negative 2x to the third, and 2 times 5 is 10. Okay, now I'm going to take this guy, negative 5 times x, negative 5x, negative 5 times negative 7x squared would be positive 35x squared, and negative 5 times x to the third would be negative 5x to the third. Now, let's write our answer in standard form and combine all our like terms. I have negative 2x to the third and negative 5x to the third. That gives me a grand total of negative 7x to the third. Now, as far as x squareds, I think I only have a 35x squared, so that guy just stays as he is. Done with that guy. Now all the x's. 5x plus 4x is 9x. Minus 5x is 4x. Done with those guys, and I got a plus 10 hanging out at the end. That's it right there. Okay, some people were trying to distribute the 5x. Don't even think about it. If there's a plus or a minus sign right there, it does not get distributed. Okay, don't make that mistake. All right, number 12. This one, you notice what's between the parentheses? Nothing. That's what tells you it's multiplication when there's nothing between the parentheses. Okay? So let's start distributing. 2m squared times 12m. By the way, there is the box method. I'm not sure if you were taught the box method or not. That works completely fine as well. Okay? I don't typically do the box method. Just out of habit, I just use this linear method. But the box method is perfectly fine. So let's see. 2m squared times 12m gives me 24m to the third. 2m squared times negative 6m squared gives me negative 12m to the fourth. And 2m squared times negative 10 gives me negative 20m squared. Okay, moving on to my next term. 7m times 12m. 7 times 12 is 84m squared. You know what, I'm actually going to write that. I'm going to try and be a little smarter about the way I write that. I'm going to write that right here because it's like terms with the one above it. That way it'll be easier for me to combine them. 7m times negative 6m squared gives me negative 42m to the third. I'm writing that guy over there because that way it's next to its like term. Just saving myself some time. 7m times negative 10 would be negative 70m, giving that guy its own column. All right, 11 times 12m is positive 132m. 11 times negative 6m squared is negative 66m squared. And then 11 times negative 10 is negative 110. So, all I got to do is add up my like terms. I think I've got them stacked up nicely here. 24m to the third minus 42m to the third is actually negative 18m to the third. My negative 12m to the fourth, I'm going to write out here because that way I've got my standard form. So negative 12m to the fourth minus 18m to the third. Now let's talk about our m squareds. I have negative 20 and negative 66 and positive 84. That ends up giving me negative 2m squared. My m's, I have negative 70 and positive 132. That gives me positive 62m. And then my negative 110. Okay, so I did that one a little bit different, stacking up my like terms. Okay, all right. And this guy, we have a division problem, and if you notice, that one's not in a nice form, which means I have to use long division. You don't like it? Sorry, suck it up. Learn it for the test, then you'll be done with it. At least until the final. Okay, so 2v plus 1 goes on the outside. Inside, I have 8v to the third plus 0v squared. Make sure you put that placeholder, otherwise you will not get there. Minus 10v plus 7. So 2v times what gives me 8v to the third? That would be 4v squared. What do I do with the 4v squared? Distribute it out here. 4v squared times 2v is 8v cubed. 4v squared times 1 is 4v squared. What do I do next? Change the signs. That becomes a negative. That becomes a negative. And then I add them together. Cancel. I have negative 4v squared. Bring down my next term, minus 10v. And we repeat the cycle again. 2v times what gives me negative 4v squared? That would be negative 2v. Now take the negative 2v and distribute it out front. Negative 2v times positive 2v is negative 4v squared. And negative 2v times 1 would be negative 2v. Change the signs. And then add those two together. That cancels out. I have negative 8v and then a plus 7. Am I done? Not yet. I still have the same degree out in front as I do down below. I have to go until I have less of a degree. So 2v times what gives me negative 8v? That would be negative 4. And now I distribute the negative 4. Negative 4 times 2v would be negative 8v. And negative 4 times positive 1 is negative 4. Change both of those signs. Add them together. Those cancel out, and I have 11. That's my remainder because now I'm a degree less than I started off with. So my answer is going to be 4v squared minus 2v minus 4 plus, that remainder is 11, over 2v plus 1. Okay? All right, so like I said, your test looks just like this. Same types of problems. We're going to have different answers, though, clearly. I wouldn't give you the test as your practice test. Sorry. Oh, I don't think I talked about points in a little while. I should probably talk about points. These three right here were all worth 7 points again. Did I do it on the last one? Nope, I even forgot that one. Number 10 was worth 10 points. And those ones I did. So, going through that, that's all your point values, so you can see where it's weighted as far as what's heavier than others. But at this point, you have absolutely everything you need in order to do well on the test on whatever day it is. I can't remember. The day after we go over this. I think it's Wednesday. So again, even if your group test grade sucks, hopefully that just motivates you to make sure that your individual test grade is going to be much better. Because remember, your individual test grade will replace your group test grade if it is better. Okay? All right. Have fun. Happy studying.